I'm Bruce Bugbee, president of Apogee Instruments, and in the next few minutes I want to show you about the latest product that we have just released for measuring daily light integral. This is it right here, tiny, very rugged. It has a microprocessor in it and records, so it measures the integral of light through the day and records it for 99 days. Really easy to use. You can download the data. We're excited about this project, this product. This meter is one that I have had running in my conservatory at our house. My wife and I remodeled, we built a conservatory for all my exotic plants. And oh God, it's been wonderful. I just, every day I go out and check the data on this thing. So let me show you what we have. So this is the meter. We call it a DLI meter, daily light integral. And I think most people, let me show you what we mean when we say that. If we make a little graph up here, let me get some pen on here. I'm going to show this in yellow. If we make a little graph and we do dawn to dusk, and if it's a sunny day, it looks like this. Nice smooth curve on a sunny day. What determines plant growth is not the light intensity to any given moment, it's the integral, this whole thing in here, all this area under here. And to do that, you need a microprocessor. Now, lots of Apogee meters have that, but they're not as small and compact, as rugged as this new meter. Shown here really big. And I'll walk you through this in just a minute. What if it's a cloudy day? Let's attempt showing a cloudy day in green. Now we get clouds like this. It still adds that all up. Day after day, gives you a different number for each day. That's the concept of daily light integral and why this is so critical to use. Meters historically haven't had this because you need a microprocessor that can do integrals inside the meter. Apogees had this before, but only in more expensive meters. This is lower cost. So let's take a look at this meter and I'll show you what it gives you. This first number right here in big, let me put this back to, let's go with blue right here. This is DLI, daily light integral. The units for this are moles of photons per meter squared per day. Now remember, a standard meter gives you micromoles per meter squared per second. And this is good, but you add all those seconds up in a day, and you add all these micros up, and you get moles. And on a typical day inside a greenhouse, you might get 18.5 moles per meter squared per day of light. This is what determines plant growth, and I'll show you some charts about how to interpret that number. It ranges in the winter outside. This DLI, let's put this in an even different color right here. The winter now, I'm recording this in winter. Winter, we might get 8 moles per meter squared per day, pretty low. Summer, we get 60. Huge difference. Inside of a greenhouse, we might get 4 in the winter and 30 in the summer, because a typical greenhouse blocks half the light. So that's why you need this for inside a greenhouse. It's also valuable for indoor agriculture because it uses you can use it as an immediate meter, but also even making sure you got the right daily light integral in your greenhouse, even though the lights are on all the time. So there's the first number, and I'll show you in a minute how it records that. In addition to this, It's also got timers in it, and it gives you photo period under here in hours to 1/10 of an hour. This helps you understand flowering in crops. I'm not going to go into short day and long day plants in this video, but photo period's a big deal. You want to know if you have light pollution, you want to know how long your photo period was. Especially for medical hemp growers, this is a very critical number to know photo period. This is because it records, it also shows you days ago, right here. So there's one of the screens in this, and we'll walk through some of these screens in just a minute. This shows you the recorded data, but what if we take this and we want to know what the light is right now? You know, I can turn it on right here, one click of the button, show what the light is in the studio. It's plenty bright to shoot this video, but look, we're only getting 4 micromoles per meter squared per second in here. Not enough to grow plants. So what's the next screen look like? Boom. This is instantaneous. I'm going to put inst for here, and this is DLI over here. You turn it on. There's our number, 164.6 micromoles per meter squared per second. So this is a rugged, portable, accurate meter for measuring what we call PPFD at all times. And then it has this additional functionality to record it for daily light integral. Notice in this screen, these 2 meters are an example of the screen. Notice one other thing. This one's blue, this one's gray. This measures, this is our classic high-end meter for doing PAR, photosynthetically active radiation, 400 to 700. This meter is calibrated for sunlight. So it's a way that we can offer you a lower cost meter that's perfectly accurate in sunlight, and then you can do calibrations of this to get other things. This is the same detector as the Apogee original quantum sensor. We just say it's calibrated for sunlight right here. This is the meter that has a square wave, a step up to give you 400 to 700 nanometers. Now, there's one more option on here. If you've listened to other videos, you know that we do EPAR. Because of our research on photosynthesis, we do extended range PAR, and we also call this EPPFD. We also have a version of this meter that does EPAR, and EPPFD 400 to 750. This is the emerging new standard for this, and for the best accuracy, this is the meter that gives you the extended range. This one is 400 to 700. This is also 400 to 700, but calibrated for sunlight. So there's the lineup. There's the 3 optional meters. This you probably can't see these tiny numbers. This is the DLI-400, and like things go, when the number gets higher, it gets more sophisticated. This one is the 500, and this one is model 600. And if you had a microscope, you could see the model number right there in these meters, and it tells you what it does. Let's take a look at one of these and how it works in the screens. And I think I can just demonstrate this to you. Chris, you want to try and zoom in on this thing? Let's see if we can show this little tiny screen as big as possible for our users. We get that. Oh, beautiful, beautiful. All right, turn it on. All you do is push the button, it's on. It's giving you PPFD just like any other meter. Now we push the button again, and it's showing days ago 0. What that means is the total so far today. So it resets, it automatically as a timer resets at night. So it gives you the total so far today, and I just turned this one on so it only shows a short photo period. If I push the button again, or when I do, it goes to 1 day ago, and this one is just here. Let's look at this one here. Here's the one in my conservatory, the one that's actually been running. Current DLI, so far today, now I'm going to push it again. 1 day ago, here in Logan, Utah, in my conservatory, I got 9.1 moles a day of photons. Now this is pretty good for winter. I have a little bit of supplemental lighting in there. It integrated the whole thing. The photo period was 14.1 hours because these supplemental lights ran longer. Now let's push it again. There's 2 days ago. What happened? Keep going. We got 14.4 hours, 11.2. That was a nice sunny day. Now 9.1 3 days ago. Let me find a cloudy day. There we go. 5 days ago it was cloudy. I only got 4.1 moles a day because of the clouds in the conservatory. Keep going. Go, 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 go. 99 days of storage. So, do you need to sit there with a pencil? Sure, you can do that, but there's more. If you take this meter, the bottom has 2 screws. You can take these out. We send you a little tiny screwdriver for this. Now this is a very well sealed meter. This is an IP65 meter. It's exceptionally rugged. Users tell us they're running this underwater in their saltwater aquariums. They're using it all over the place. You can spray it with hoses. It's amazing. So it has really good seals. So you take this little post that's supplied, you can screw it in like this and pull the bottom out. Now there's the batteries, there's the bottom, but right here, Chris, when you zoom in on this little thing, I think I got a slide of this too, but we'll show it live. There's a little USB-C port, and we give you a cable, plug that in, boom, download the data to your computer. So you can download the past 99 days of data with this cable as soon as you take the bottom off. Then when you've got it all downloaded, pop the bottom back in, and you're good to go with the screwdrivers. Now, let me show you what else you can do with this little cable. This is made to help mount it. Notice at home, I have a little tiny tripod, and I mount it. I can move it around nice. But it also comes with a little stake. So if you have containers, just put her in a container. There you go, you're good to go. It's mounted. So, a lot of mounting options. Let's go back to these slides now and go into some more detail here. We have been testing this thing in many greenhouses in many places both for ruggedness and for examples of mounting, and that's what we want to show you here. Here's a nice poinsettia crop on the top of a tripod in a grower's greenhouse. Some lettuce on a tripod right here. Another example of mounting, here it's on the end of a cross arm. There's lots of ways to mount this. Here's that little stake in a pot, and here it is on one of our platforms. This picture shows you a bunch of things. It's rugged. We've done a lot of testing on it and a lot of mounting options. We have yet to have any failures, and like I say, it's IP65. Let me review that for a second. Let's go back to this slide so I got room to write, and I'm going to attempt to, now I've just put it up here. IP65 is a rating of how resistant it is to dust and water. We used to think IP50 was good, and we get better seals when we get to IP55. This is 65. This one stands for dust. Any kind of dirt getting into it, it won't get into it. It's very sealed. 5 stands for water. And so it's 2 digits. That the higher you go, the better sealed. that's exceptionally well sealed. All right, now let's get back to this. Here it is. Here it is with some medical hemp in a greenhouse. This has been really helpful to medical hemp growers. Let's take a close look at the screen, just to review. Instantaneous, the screen goes up. It measures high numbers in micromoles. Again, micromoles per meter squared per second. Real simple. That's just the standard mode. If you go to the screen, that recording screen gives you the DLI in moles, photo period in hours to 1/10 of an hour, and then how many days ago. Every time you push the button, you go back 1 day. At the end of that, you just put a long push and it resets right to 0. This meter, once you put the batteries in, the meter turns on and it automatically runs. In the background, the meter is always on. The screen will go blank to save battery power, but it's always running. That's a unique feature of this. Batteries last 6 months. Two AAAs, very quick to change the batteries. It saves all the data when you change batteries. But it's always running in the background as soon as you put the batteries in. Here's what I just showed you, only big. There's the USB cable. There's the batteries. They're in a compartment. This is gasketed in the bottom. And then right in here, it's hard to see here, is the USB for downloading the data. This is what the screen looks like once you download the data. It's just a standard Excel file. I don't know if you can see this, but days ago is right here. DLI on that day and photo period on that day. So it tells you what's going on. Now another feature that we put into this was 30-minute averages for light intensity for the past 10 days. Because sometimes you want to know, is it partly cloudy? Was it bright and sunny? So here's days ago and a 30-minute average. Let's do that in blue. 30-minute average of PPFD. Look at this data. If we graph this data, we get up to 500. So this is a nice sunny day. If we graph that data, it'd look like this. And we'd get up to 500 in the middle of the day. Not a sunny summer day, but still gives you the average for the day. DLI. Let me walk you through the interpretation of that. Jim Faust, Dr. Jim Faust, one of our great colleagues, visited the lab, has done a lot of work helping people interpret DLI numbers. This is just a generic chart on DLI in moles per day. This is moles per meter squared per day. They didn't put the DLI in this chart. Remember I showed you some numbers. I was getting about 10 in my greenhouse in the winter at home. Okay, here's a list of crops. These are all flowering ornamentals. White means too low, can't grow it. Yellow means just barely. It's going to struggle. It's going to be floppy. Green is better and red is excellent. If you got red, you get plenty of light. So at 10, I could grow most of these crops. I would have some trouble with crops down here, not quite enough light. If this was medical hemp, the more the better. We would want to be up to 20 or even 30, and now we go off scale. We go even higher than 30 with medical hemp. So and lettuce, we'd like to be up in this region. This doesn't have lettuce. We'd like to be up in this region here for lettuce, 16 to 20 moles a day. This meter tells us if we get there. If you search the internet for James Faust DLI, you will get a series of maps for average DLI for places in the United States on average and with the season. This is not inside a greenhouse. This is just outside. Here's January DLI, and man, these numbers are purple. I mean, up in here, this is just not enough light to grow plants. We put supplemental lights in. Down here, it's still low. But you can look at typical DLI values on average from a month at a time from this website. There's James Faust right there. He's at Clemson. And if you follow football, you know about the Clemson. I won't say any more than that, but they've had a good year. So, let me close on this. I think I've said everything I want to. Why is photoperiod important? Some crops are short day, some crops are long day. And the short day crops need to be below a threshold. Medical hemp is a short day crop. Typically, we want that to be less than a 12-hour photoperiod. If you're getting photoperiods 13, 14 hours, you're going to have trouble getting hemp to flower. Long day crops flower faster in long days, and many of our crops are long day plants. Wheat is a long day crop. So you want long photoperiods for those. That's where the photoperiod comes in. Now there's one key thing about this new DLI meter that I got to share with you that's not so intuitively obvious, but we have come to this as we look at crops, medical hemp and a lot of other crops in the field. As you know, Apogee makes a light bar for measuring light penetration to the bottom of the canopy. And if light gets to the bottom, those photons are wasted. So you want to capture the light. But that light bar only works per second, and you measure above and below the canopy. But in a greenhouse, the sun moves and through the sky. So how are you going to integrate that light capture through the day? Well, you can use the DLI meter to do that. Let me give you an example. Here's a bunch of crops, right? We get leaves all over the place here for a crop. If we put, and we'll put this DLI meter up here in yellow, 1 meter up here for incoming light, and it comes at all angles through the day, like this. And then we take a second meter and we put it down here at the bottom of the crop. Now, this also integrates the light through the day at all angles. So the difference, this is in, this is out, and in minus out, oops, that's a minus, in minus out equals absorbed. This is a really powerful technique to tell how your canopy is doing, how much light capture did it get. And 2 sensors like this give you the daily light integral for both of them in a way that you can't get if you just have a single meter once a second in here. You want to integrate all the light. So this is a creative use of this that's been really useful for us in our research. Now, following in this same principle where we're doing capture, how about you have your greenhouse right here, your greenhouse roof. What's the penetration of photons inside your greenhouse? If you mount one out here and you have one inside, this doesn't have to be straight above, just above the greenhouse, the ratio of these, this is the same math, in minus out equals absorbed. And you'll be surprised at how much greenhouses absorb. A typical greenhouse can absorb half of the photons. And then people go up and clean the glass and they go, oh my God, we should have done that years ago. This really helps to make sure your greenhouse is clean. It's the same thing with even electric lights. Do you need to clean electric lights? Getting a ratio of in and out integrated through the day. So both of these have been really useful for this meter. So, I'm going to close on this slide. Here's the 3 models, the 400, the 500, and the 600. If you search for Apogee DLI Meter, you'll come right to this page. This is an exciting development. We've been refining this for some time to get peak accuracy and peak functionality. We've had prototypes out with a lot of people to give us feedback on how to do this. For me, this is one of the most exciting things we've introduced in a while. I think it's really going to help our users. Let me mention one final thing. If you want to know the level up from this, the light during the night and more detailed data, you still can buy our micro cache with sensors and download that data to your phone. This gives you more detailed data than the DLI meter, but it's also more money too. So there's still multiple options for measuring this. Thanks for listening. We'll pick this up in the next video.